Okay, so somebody asked earlier, what does this have to do with what we've been talking about? We've been working on logs and natural logs. Well, I'm glad you asked. So now we're asked to find the time. So let me read it to you. It says Judy has $500 to invest at 9% annual interest compound monthly. How long will it be for her investment to grow to $3,000? So her principal is $500. Her rate is 9%. Why did I write it like that? Her rate is 9%, which is 0.09, right? And then we don't know the time because that's what they're asking, but we know that her final amount is supposed to be $3,000. And it says it's compounded monthly, which means that K must equal 12 because it's done 12 times a year. So I'm going to use the formula A equals P plus 1, or times the quantity 1 plus R over K raised to the K times T. Problem is I got to figure out what T is. T is trapped in the power of the exponent. The easiest way to get that out of there is to use some sort of log. I know I'm talking fast. I'm thinking faster than my lips can move, so I can't always form complete sentences. So at some point in time, I'm going to have to hit the left and right hand side with a log. Then I use the property of the log to toss that power to the front, and then I can solve algebraically from there. So let's plug in the numbers. I've got 3,000 equals 5,000, or 500. 1 plus 0.09 all over 12, and that's raised to the 12t. You guys with me so far? And we got to solve for this t. So our goal is to make it look like t equals some stuff. So I got to get t by itself. So I slowly move stuff away from the t. Going to divide both sides by 500. Hey, that worked out nice. I got 6 equals the quantity 1 plus 0.09 over 12 raised to the 12t. Now, if I want to, I could do this. I could add this up on the calculator and get a decimal for it. Okay, so let's do that. I'm going to say 1 plus the quantity 0.09 divided by 12, close parentheses. See how I did that? I'm going to hit enter. I get 1.0075. And that is going to go here. So I've got 6 equals 1.0075 raised to the 12t. And I want to get that by itself. Does that make sense so far, guys? So now at this point, if I hit both sides with the natural log, what I can do now is there's that property of natural logs that says that I could rewrite my natural log as 12t times the quantity, the natural log of 1.0075 is equal to the natural log of 6. That make sense so far? You guys with me? Now I want to get t by itself. So if I divide the left-hand side by 12 times the natural log of 1.0075, this cancels, this cancels, this cancels, this cancels, and I've got 12 times the natural log of 1.0075. So t is equal to the natural log of 6 all over in parentheses 12 times the natural log parentheses 1.0075 Now, you don't realize this, but everything on the left-hand side of the equal sign is a number. I just got to plug that in the calculator. I got a number over a number, I'll have a number, and that'll tell me how many years. All right? So what I'm going to do is I'm going to plug that in my calculator. We said that the natural log of 6 divided by, start my parentheses, 12 times the natural log of 1.0075, close. See how I entered that in the calculator? When I do this, you guys should be doing it too. I'll give you a second. Go ahead, plug that in your calculators. That's how you get good at this sort of thing. And when I hit enter, I get 19.98. What does that mean? Well, it takes about 20 years. That's what that means, okay? That means that T is around 20 years because actually this is like 19.983, right? So in regular English, if you take $500 and you put it in an interest-bearing account at 9%, which by the way is phenomenal, and it's compounded monthly over 20 years, you'll go from $500 to $3,000. Does that make sense? Okay. Any questions? No?